So everyone, very good morning, and that is topic on resonance and locus diagram part 3. Okay, then this is my introduction. Myself Sanjay Rathi, 24 years of teaching experience. I have qualified and selected for engineering services exam that is conducted by UPSC. These are my ranks, and I have trained more than 1 lakh students for these competitive exams, especially for GATE and engineering services. Okay. And that is my Telegram channel, Electronics by Sanjay Rathi. You can join, you can download the PDF from that. You will get the idea about the coming exams and important notes. Then guys, till now we have discussed what series resonance and parallel resonance. Quick revision. Yes. Now, this was the RL circuit. Everyone, you can watch the recorded lectures. This is the RL circuit. This is called series RLC circuit, and then parallel RLC circuit, guys. Parallel RLC circuit. Okay, remember, here we are finding impedance R plus J omega L minus J by omega C, and that is given by R plus J omega L minus 1 by omega C. Exactly at resonance, that imaginary part is 0 and we are getting the minimum impedance R, right? But here we are finding the admittance, that is 1 by R is G. Because of that, it is J omega C, that is the YC, and that is the YL. And that's why when we are making the imaginary part 0, you will get the minimum admittance and therefore maximum what? Impedance. So Z is maximum. That is 1 by G, that is nothing but R, but this is maximum. Now, what is the comparison? In a series resonance, these two act as what? Short circuit. Parallel, a series combination of L and C act as short circuit in a series resonance. But in parallel resonance, it will act as open circuit. Open circuit. Then, here, we are applying the voltage, and because of this voltage, we are getting the current. So what is the phase difference between voltage and current under resonance? 0. And the impedance is purely resistive. Power factor is unity because there is no phase difference between voltage and current. Same logic here. We are applying the voltage current here, like it is the current, and we are developing a voltage at this point. So what is the phase difference between voltage and current at the resonance? 0. And that's why again the cos factor theta, that is the power factor, is 1. Power factor is unity, and admittance is real part, and that's why the impedance has only real part. There is no imaginary part. Okay, so these are the important points. Now guys, another important point is what, when we are talking about the series resonance and parallel resonance, remember, in series resonance and in parallel resonance, simply when we are moving from series to resonance, R should be replaced by 1 by R, C should be replaced by L, and L should be replaced by what? C. So you can directly give the quality factor omega naught L by R, right? It is also represented by 1 by omega naught RC. This is for series resonance. Bandwidth, that is given by omega naught by Q, or that is also given by R by L, where omega naught is the resonance frequency, 1 by root over LC, right? It is in radian per second. If you want in hertz, then you have to find by omega naught by 2 pi. That it will become 1 by 2 pi root over LC. Remember that. It is in hertz, it is in radian per second. Okay, then this is the resonance frequency, that is the quality factor, and that is what? Bandwidth. Now in a parallel resonance, same thing. In a parallel resonance, quality factor is given by 1 by omega naught, right? Remember, this is the reciprocal of that, just opposite. So it will become omega naught RC, or that is just R by omega naught L, right? Then second, bandwidth. Bandwidth is here, R is replaced by 1 by R, L is replaced by C, the bandwidth is 1 by RC. The bandwidth formula for the bandwidth is omega naught by Q, it will remain same. Where the omega naught, it will remain same, 1 by root over LC. Why? Because L is replaced by C, C is replaced by L, we are getting the same formula, omega naught is equal to, okay. And then that is the relation, F naught and omega naught will remain same. So this is the quick revision, guys, between series and parallel resonance. So first of all, you can make short notes like this. Short notes like this. This is the series resonance, that is the parallel resonance. Impedance we are getting the minimum. Here admittance we are getting the minimum. Impedance maximum. Admittance minimum. Okay. The admittance यहाँ maximum. वहाँ पर impedance maximum. Now these are the formula. R is replaced by 1 by R. If you want to get the formula between series and parallel, then this is the R is replaced by 1 by R, C is replaced by L, L is replaced by C. The main formula is quality factor, bandwidth, and the resonance frequency, and so on. And there is a half power frequency, that is also known as half power frequencies. So in series and parallel, the formula for the half power frequency will remain same. What is the formula for the half power frequency? Minus alpha plus root over alpha square plus omega naught square. This is called lower cutoff frequency, and this is alpha plus root over alpha square plus omega naught square. That will remain same for series or parallel. But what is the value of the alpha for the series? It is R by 2L. And what is the alpha for the parallel? It is 1 by 2 RC. And that is the difference. What is the omega naught? Omega naught will remain same, 1 by root over LC. This is also omega naught is 1 by root over LC. Right? So simple hai, L is replaced by C, C is replaced by L, and R is replaced by 1 by R, and L is replaced by what? C. You will get this formula. This is called half power cutoff frequency, or lower cutoff frequency and higher cutoff frequencies, guys. So this is the very right. So this is the just a quick revision. Just I have started the class. So this is the quick revision between the series and what? Parallel resonance. This is the series, and this is what? Parallel. Okay, in this way we can make what? Short notes, but no need to refer anything. Write all. Try to recall the formula, try to recall the important points, and on your copy please try to write all this. It is called quick revision also, right? So quick revision. Very good morning everyone. Sure. Okay, no problem. Now that is a series and parallel. Then guys, today's topic is what? First of all, we will cover the topic, then we will solve important numericals. Locus diagram. Now we have learned about the series resonance, we have learned about the parallel resonance, we have solved some important numericals also. Now what is the locus diagram? So in electronics branch or electrical branch, in engineering services exam, in GATE exam, we are getting some important question on locus diagram. So just I want to give you the idea what is the meaning of that and how to draw the locus diagram. For example, in case of RC circuit, for example, in case of RL circuit, for example, in case of RLC circuit, guys. Okay. Now with the automatically you will get the idea. For example, in case of RC circuit, for example, in case of RC circuit, how we can draw the locus diagram. What is the meaning of this? Let this is R, this is C, and we have applied a voltage here V, and there is a current I. Right now there may be R is variable, there may be C is variable, or there may be omega is variable. So there are three things that may be variable: R, omega, or C may be variable. may be variable. Okay, if R or omega or C, any one of these, R, omega or C variable, then what about the impedance? Impedance will vary. What is the impedance? R minus J by omega C. This is the impedance because of the RC circuit. So what is the magnitude of the impedance? Root over R square plus 1 by omega C square. Now phase of the Z will also vary. What is the phase? Minus tan inverse 1 by omega R C. Imaginary part upon real part, that this is also vary. If the omega will vary or any one of this, R vary or omega vary or C vary, magnitude will vary, phi will vary. What is the V? What is the I? I phasor is given by V by Z. And if the Z will vary, then definitely there is a change in what? I. If the V is remain constant, right? V remain constant, then what? I will vary, and we have to plot I, and then finally we will connect all the points, and that is called locus. That is called what? Locus. So you can draw the locus diagram for Z, you can draw the locus diagram for I, right? And there is a change in I too, because when we are writing like this, for example, this is V, let the phase of the V is 0, so V is replaced by the magnitude of V, angle is let 0. Then Z is mod of Z, angle is phi. Then what is the I? I will become upon mod of Z, angle phi. Then this will become negative. What is the I? V by Z magnitude, and angle will become minus phi. Always remember, in case of impedance, if the angle is positive, it will become negative here. If it is negative, then it will become positive here. So we can represent like this: magnitude of I, angle of I. What is the theta I? Minus of phi. Phi is the angle of what? Impedance. It will become positive here. It will become positive here. So that is the basic things. Basic. So first of all, RC circuit, there may be V is a constant, maybe R variable, maybe omega variable, or maybe C variable. Any one of these three are variable. So that impedance will vary, because impedance depends upon R or omega or C. Then phi, the angle of the Z will vary, that impedance will vary, tan inverse 1 by omega RC. When this will vary, means what about the I? I will vary because V is constant, Z is variable. So magnitude as well as phase, both will change. Magnitude will change as well as phase will change. This is called the magnitude, and that is the phase will change. Now we are going to plot the tip of this phasor. This is the phasor. So when we are connecting all the tip, that we are getting the locus, and that is called locus diagram. So this is the RC circuit. So one by one, how to draw the locus, I will give you the idea, and then we will solve some numericals on this. This is the RC circuit, guys. Okay, so first of all we will take R as a variable, then second we will take omega or C, one of these, and you will get the idea. And variable means we are going to vary R from 0 to what? Up to infinity. If suppose we are going to vary the omega, then omega will vary from 0 to infinity. Or C means C will vary from 0 to what? Infinity. Then what is the effect on impedance and what is the effect on current? Then we have to plot. Okay. Then now, so first of all get the idea कि क्या है, what is the C and what is the R, all the important. Now I am going to vary the R, then after that C or omega. Any one of these, you will get the idea how to plot the locus. In GATE exam, in other competitive exams, we are getting the question. Yes, please. Any doubt up to this point? Okay then. Now that R is variable. Let R is variable. So what is the effect of R? Okay. These two formula will remain same. Now, if R is variable, then what about the magnitude of Z? What about the phi? And then I and then angle of I. Okay. And then we will draw the diagram, guys. Okay, watch it carefully. For example, if the initially we are taking the R is equal to 0. If the R is 0, then it will become Z is what? Minus J by omega C. So what is the magnitude of Z? Because it is 0, it is the magnitude is only 1 by omega C. What is the phi? Because R is 0. 1 by 0 means what? Minus 90 degree. Why? Tan inverse of infinity is minus 90 degree. Now what is the magnitude of I? Because this voltage is fixed and the impedance is what? Then what is the magnitude of I? V divided by what? 1 by omega C. So it will become omega CV. Because V divided by that value, so it will become multiplication omega CV. And what is the phi negative of that? Minus phi is what? This is the phi. It is become minus plus 90 degree. So if it is minus, then it will become plus. This is the phase of what? Impedance. And that is the phase of current opposite. Plus 90 degree. We are taking the voltage as a constant. Now, so that is the value. Now we are increasing the omega. We are increasing the R, sorry. When we are increasing the R, suppose I am going to put the R is equal to what? We can put R is equal to 1 by omega C. That this is the value. R and omega C both are equal. So I am going to put the R is equal to what? 1 by omega C. Right? 1 by omega C. If suppose I am going to put the R is equal to 1 by omega C, then it will become what? R square plus same thing R is, or this one. Then it will, what is the magnitude of that? Root 2 times of that. Root 2 times of omega C. An angle. Put the here R is equal to 1 by omega C. So it will become tan inverse of 1. What is the tan inverse of 1? 45 degree. And then what is the current? Current will become omega C V by root 2. Means that is this is the maximum current and it will become what? Root 2 of 1 by root 2 of that value. And if this is minus 45, this will become plus 45. Finally, you can take R is equal to 0, infinite. Finally, you can take R is equal to what? Infinity. If it is infinity, impedance will become infinite. If the impedance is infinite, then what about the phase? Because the R is infinity, 1 by infinity 0, it will become 0 degree. What about the current will become 0 degree? What about the phase of the 0 degree? This is the table. So first of all, focus on the table. And that is the formula, guys. Remember, I is equal to what? V by Z, and you will get mod of I angle phi. And therefore, phi I is equal to what? Minus phi Z. That is the case. So you can get the complete table. Now you can draw the locus. You can draw the locus diagram. Watch this. What is the tip? What is the meaning of the tip of the phasor? Now, like we are taking just V. It is a 0 degree, na? So this is the 0 degree. So this is 90 degree. and this is what? Minus 90 degree. This is V, right? This is a V. V is here in this. Now, first watch it. When the R is 0, what is the angle of current? 90 degree, plus 90 degree. And what is the value of that current? Omega C into what? V. Plus 90 degree, where is the plus 90 degree? Here. And what is the value? Omega CV. So omega CV means you can just draw a phasor here. And what is the value? Omega CV here. That this is the omega CV. And this is the value for R is equal to what? 0. R is equal to 0. That is the value of current. Now when we are increasing the current, when we are increasing the value of R, current start decreasing. And it will become what? Omega CV by root 2 exactly at what? When 1 by omega C. And finally it will become 0. And angle is what? 45 degree. So you can draw, when we are drawing all the phasor, you are going to get what? Semicircle here. You are going to get the semicircle here. Just I am going to draw it. And then I will explain this. One minute. Like this. Then finally enter here. When R is what? Infinity. What is the angle here? 0. This is a, it will make a, this line will make a tangent with this. So this is the angle is 0. What is the magnitude of the current? It will become 0. Now when R is 1 by omega C, the value is what? 45 degree. 45. Angle is what? 45. And the magnitude of this line is omega CV by root 2. Omega CV by root 2. So when we are talking about the phasor or locus diagram, means we can take the infinite value of what? R from 0 to what? Infinity. Then just like this, exactly at 0, this is the value. For other value, this is the value. Then and so on. What we are doing, just we are connecting the tip of phasor, and that is called locus diagram. So we are getting a semicircle. We are getting a semicircle where 3 points are important. Exactly at 0, what is the magnitude of the current? Maximum. This is the maximum current. And at 45 degree, you will get the 1 by root 2 of the maximum. And exactly at this infinity, exactly when the R is infinite, you will get the 0 current. And this is the semicircle. In which quadrant? That is in first quadrant. That is important. That is in first quadrant. This is the first quadrant. This is the fourth quadrant. Now here in this first quadrant, current leads voltage. Current leads voltage. Yes, in capacitive circuit, current leads the voltage. When it is purely capacitive, means R is 0. What is the phase angle? 90 degree. When it is purely resistive, right, means R is what? Infinite, because R is variable. So R is infinity, then at that time angle becomes 0, but the magnitude of the current is what? 0. So that is the, this is called what? Locus diagram, right? So we have just connected the tip of phasors. When we are making the R variable, you will get this type of diagram. Okay. Any doubt in any line? So that is a question, guys. Draw the locus diagram for RC circuit. If the R is variable, then this is the current. We have just plot the current I phasor. You can also draw the Z phasor. You can also draw the admittance phasor. So just I am going to draw the Z for this and then Y for this, and you will get the idea. Then I will vary the omega and what C other than that. Okay then. If you have any doubts, then you can write in comments. Now, same formula, same variable, just you can plot what? Z here, because we have the value of the Z, phi Z. You can plot the Z. I am going to plot the Z. Just remove this one. Remove this one. This was the current phasor. Okay. Now, impedance. For example, if you want to plot the impedance, remember this is the 0 degree, this is the 90 degree, and this is minus 90 degree. Suppose you want to plot the impedance, you don't want to plot the current, then only impedance. Then when the R is 0, what is the magnitude? 1 by omega C. What is the angle? Minus 90 degree. Where is the minus 90 degree? Yes. Okay. So when the R is 0, so now watch this. So first of all, go through the first one. When R is infinity, so what is the Z? Infinite. And what is the phi Z? By 1 by infinity. 1 by infinity means what? 0. So what is the tan inverse of 0? 0. Right. So what is the current? Because the R is infinity, Z is infinity, current, magnitude of current will become 0. It is 0, that's why it will become also 0. Because it is a minus of phi Z, so this is 0. So phi Z will become 0, that is the 0. So you have to draw the locus diagram for 3 values. Or remember, you can draw for the 2 values and there is a semicircle. When R is 0, what is the magnitude of the current? Omega CV, and what is the angle? 90 degree. So first of all, plot this point. And second point, when R is infinity, where R is infinity, what is the current? 0, and what is the angle? 0 degree. So it will make a tangent with what? 0 degree. So that's it. Now draw a semicircle in a first quadrant. Why? Because in first quadrant angle will vary from 0 to 90 degree. This is a semicircle. And then a white line, this is a white line. You can draw a line where the angle is what? 45 degree, and that it will give you the magnitude. Omega CV by root 2. Omega CV by root 2. What is the magnitude? Omega CV by root 2. This is 1 by root 2 of maximum. What is the maximum value? Omega CV. Now they can ask, what is the radius of the semicircle? Half of this. Radius of the semicircle is omega CV by root 2. Radius. It will become omega CV by root 2. This is the radius of semicircle. So it will be in first quadrant, angle will vary from 0 to what? Infinity. And then phi Z is 0. So what is the phi I? It will also become 0 because it is a negative of that. I think now it is clear. So this is a phasor diagram. So you have to draw only the 2 points and recall the angle. If angle is what? Positive means it is in first quadrant, it will vary from 0 to 90 degree. Now get the idea about the Z, you will get the how to plot the locus diagram. This is the first one. If suppose it is given, draw the locus diagram for Z. Yes, you can draw impedance. If it is Z, then first, when the R is 0, what is the value of the Z? 1 by omega C. What is the angle? Minus 90 degree. Where is the minus 90 degree? This one. This is the minus 90 degree. Right. And what is the value? 1 by omega C impedance. Value of the impedance is 1 by omega C. This is for R is equal to 0. Value is 1 by omega C. So when the R is infinity, what is the Z? It is also infinity. अब देखो यहाँ पर क्या होता है, प्रॉब्लम ये आती है कि जब आप इंफिनिटी पे प्लॉट करना है, then भाई अब आ गया ना, this is not having the finite value. This is not having the finite value. Then you can't So in that case we have to use the concept of what? Control system. Okay? So when the R will increase, what about the angle? Angle will decrease. And then what about the magnitude of the impedance? Increases. And ultimately it will reach to what? Infinity. So you can plot a one phasor only exactly at 45 degree. This value increase. And what is that value? Watch this. What is this value? Root 2 times of omega c. Right? And finally at infinity, when R is infinite, it will become infinite. So, and what is the angle? 0. So you have to draw up to what? Infinity, but practically it is not possible to show. So at omega R is equal to infinity, it will become infinite. It will become what? Infinity. Impedance will become infinity, and that is the range, and that is the length of this phasor is what? Infinite. Practically not possible to show, and that's why we are representing what? Admittance. That's why we are representing what? Admittance. So that is the phasor. Watch this. What is the angle? Minus 90 degree. What is the angle here? Minus 45 degree. And what is the angle? 0 degree. This is the angle 0 degree. And what is the length of the phasor? Infinity when R is infinity. What is the length of the phasor? Root 2 by omega c. Then, if suppose you are going to draw the admittance, then you will get the proper plot for this. What is the admittance here? Now watch this. If you want to plot the admittance, what is the magnitude of the admittance? That is the 1 by z. What is the angle of that? That will become negative. Because 1 by z, so that's why it will become angle negative. So if it is 0, R is 0, but what is the z? 1 by omega c. So what is the omega c? It will become reciprocal of that 1 by omega c, omega c. If it is minus 90, it will become plus 90. If it is root 2 by omega c, it will become omega c by root 2. And it is minus 45, it will become plus 45. It is infinity. Z is infinity, it is 0. What about the admittance? It will become 0. And angle, just discuss negative, and then that is the 0. So we are getting the phasor for what? Y, just like what? I. Same, similar. And that's why number of numericals I is given. You have to plot the phasor for I or phasor for what? Admittance. Both similar type. Why similar type? Because current is equal to V by Z, or what? YZ. It is directly proportional to admittance YV. And if the V is constant, so I phasor and V phasor is almost similar. Then we are getting, for example, if it is 0, then what is the value? Omega c. And angle is 90 degree. Same, just like a current. If it is infinity, what is the value? 0. And angle is 0 degree. This is the point. What I have said, draw the semicircle. But what about all the angles? It will vary from 0 to 90 degree. So this is the 0. This is 90 degree. So draw a semicircle like this. This is the semicircle. And you can also draw a line at 45 degree. This is at 45 degree. And what is the value at the 45 degree? Omega c by root 2. And that is called admittance phasor. Admittance phasor. Locus diagram. Admittance locus diagram. So watch the admittance locus diagram and current locus diagram. Similar. Current locus diagram and admittance locus diagrams are similar. Only remove the V. It will become omega c. It will become omega c by root 2. This is the omega c. What is the length of this phasor? Omega c by root 2. And what is the value at 0? This is the R is equal to infinity. We have started from R is equal to 0. And at this point you have the value R is equal to what? 1 by omega c. That is the case, guys. And always remember there will be arrow like this, means R increases. When R increases from 0 to what, infinity, that is the path. That is the path, right here. R increases from this point to this point. So Z is not possible. Z is, in this case, Z is not possible, and that's why we are giving the phasor of I, or we are giving the phasor of what, Y. Now tell me, is there any doubt? Y phasor and I phasor is similar. Now RC circuit, just quick revision. In RC circuit, R may be variable omega or C. We have to give the variable values of the Z and variable values of I. If suppose R is variable, then first of all draw the table, proper table, and then plot it on the diagram, and you will connect all the tip of the phasor, you will get the semicircle in a first quadrant if R is variable in RC circuit, right? And that is the value. From R is equal to 0 to R is equal to infinite, you have to vary. And remember, just draw the arrow, okay, and that is the case. Now in the same thing, I am going to vary what? I am going to vary omega. If suppose the omega is variable, then what will happen? Same table, let the omega is variable. The omega is variable. Omega frequency is variable, that formula will remain same. This formula will remain same. There is a change in what? Phasor diagram only. Okay, that is the diagram. This is 0 degree, 90 degree, minus 90 degree. And the we have taken the V, angle of V is what? 0 degree. Okay. Now which one is variable? Omega is variable. When the omega is variable means that term will vary, 1 by omega C will vary. So please focus on that. C is constant, R is constant, V is constant, only omega is variable. Now if omega is 0, 1 by, watch it, 1 by 0, 1 by 0 means this term will become infinity. So what is the overall impedance will become infinite. Overall impedance will become infinity. So what is the phi z? Phi z means this is the phi z. If it is 0, 1 by 0 infinity, tan inverse of infinity is what? Minus 90 degree. When the impedance is infinity, what is the current? Current will become 0. And what is the angle of phi I? Minus phi z. It is minus 90 degree. Minus minus plus 90 degree. Because phi I is equal to minus phi z. It will become plus 90 degree. Now it is clear. So omega vary. So omega, it is impedance is inversely proportional to that. So it is 0 then. Now you can take omega is equal to what? 1 by RC. If you are putting the 1 by RC, put here 1 by RC. So C cancel and it will become R square. R square, it will become root 2. Root 2 times of R. You can check root 2 times of R. Then what is the phi z? If it is 1 by RC, RC cancel, tan inverse of 1, it will become minus 45 degree. Minus 45 degree. What is I? This is the root 2R. So what is this? V by root 2. Magnitude will become V by root 2R. And what is the angle? If it is minus 45, it will become plus 45. And finally, you can take omega is equal to what? Infinity. If omega is infinity, 1 by infinity, that term will become 0 and impedance will become minimum. What is the minimum impedance? R. What is the angle? If the omega is infinity, 1 by infinity, 0 degree. 1 by infinity, 0. Tan inverse of 0 is 0. Then when the impedance is minimum, it is decreasing. From this point to this point, it is decreasing. So what about the current increases? And what is the maximum current? V by R. Maximum current V by R. And what is the angle? 0. Fine. Because it is now, it is a purely resistive circuit. And that is the variation what of omega. So omega, here you will get the infinite to that. That's why it is not possible to draw the locus diagram for what? Z. So you can draw the locus diagram of I, or you can draw the locus diagram of what? Admittance. Both will have the same, because it is inversely. Already I have given I is equal to V by Z or Y V. So that's why now you can plot. So first of all, draw the table variable value, or you can take also the two values, 0 and infinity. So here the current is 0. When omega is infinity, current is what? V by R. What is the angle? All angles are positive. 0 to 90 degree. Means in which quadrant? It is in first quadrant. So first of all, draw. When the omega is infinity, what is the value? V by R. So you can plot here with 0 degree. With 0 degree means it is the line. Right. When the omega is infinity, what is the value of current? V by R. This is the current phasor. So this length is what? V by R. When the omega is 0, what is the current? 0. And what is the angle? 90 degree. This is the 90 degree. And 0. So there will be a semicircle like this. I can also draw a semicircle with this. Let's try. Okay. Yes, this is a semicircle. This value is omega equal to infinite, and this point is omega equal to what? 0. Now remember, when the omega is 0, current is 0. When the omega is infinite, current is what? V by R. So omega will vary from 0 to infinite like this. And that is the plot. Or angle will vary from, this is the 90 degree because it is parallel toward this line, and at this point the angle will become 0. And exactly at 45, you can also plot a line at 45 degree. This is the 45. Now what is the length of that 45? 1 by root 2 of the maximum current. 1 by root 2 of the maximum current. This is the V by root 2R. And this is the angle is what? 45 degree. So this is the tip of the phasor we are just connecting. And that is the locus diagram in first quadrant. And what is the radius of that? Radius is equal to V by 2R. Always remember, radius means half of that. V by 2R, V by 2R. So this is the omega is variable. Is it clear? So in first case I have taken R variable, in second case I have taken what, omega variable. We have plot curve for I or admittance. Just our observation, I and admittance have the same type of locus diagram. Then we are getting the semicircle. What is the radius of the semicircle? That is important. Any doubt, any calculation mistake, you can inform me. If you have any doubts, then you can write comments. बोलो जरा भाई. Okay. This is about the RC circuit. If suppose you are going to vary the C, again you will get the same answer. C is or omega. C or omega. Sir, I is infinity, then nahi hoga. In first case, omega is 0. How the, array, there is a R also. When the R is there, na, R will control. If omega is 0, then Z will become what? 1 by 0 is what? 1 by 0 means what? It will become infinite. So Z will become infinite. So what about the current? Inversely proportional to Z, na? If the Z is infinity, then what is the R? What is the current? Current will become 0. Z is infinity. What is the V by infinity? 0. Current is 0. Okay. So remember, it is in denominator actually. So what the V by Z, and that's why I have written this. If the Z is infinity, V by Z, it will become what? 0. If suppose you are going to vary the C, same you will get omega or C, same result. It is 0, it is 1 by RC, it is omega, it will become 1 by omega R only. Whether we are going to vary the omega or we are getting the C, we are going to get the same type of plot, because it is in same position, omega or C. We can vary omega or we can vary what? C. Okay. So there is an assignment, draw the locus diagram when the C is variable. You will get the same result. Okay, now for RL circuit, guys. Now for RL circuit. Very easy. When I am talking about the, okay, locus diagram means always watch the table carefully. No, that was not the locus diagram. No? 1 minute. Okay. Locus diagram means what? First of all, draw the line like this, right? 0 degree, 90 degree and minus 90 degree. Then first, when the omega is 0, what is the current? 0. This is the 0. Now, what is the omega is infinity? What is the current? V by R. And what is the angle? 0 degree. So, bus draw the two plot. V by R means this is the V by R. Phasor. This is the V by R. But this value is for omega equal to what? Infinity. Omega equal to infinity. So, we are now having the 2 points. This is for omega equal to 0 and this is for omega equal to infinity, and this is the now. Now remember, draw a semicircle, but in which quadrant? Watch the angle. Vary from 0 to 90 degree. So it will vary from 0 to what? 90 degree. Right? Draw a semicircle. This is the semicircle. Finished. Now omega will vary. Omega increases from 0 to what? Infinite. So current initially it is 0, now increases. Now watch this. This is the making a tangent with this. So what is the angle here? 90 degree. And now it is a straight line. So it is what is the angle? 0 degree. Exactly at 45 you can draw. This is the at 45. Exactly at 45 the angle is what? Plus 45, and what is this? V by root 2R. So this is the length of the phasor is V by root 2R. And this length is what? V by R. And what is the radius? Half of that. V by 2R. This portion is also V by 2R. That is called locus. It will vary from 0 to what? Infinite, and angle will vary from 90 degree to what? 0 degree. Okay. In this way we can plot. Again it is in first quadrant. Because we are plotting what? I. But here the omega is variable or C is variable. Suppose you are going to vary the C, again you will get the same type of diagram. Again you will get the same diagram. So I can write also omega vary or C vary. Same. Because C is also in denominator. Okay. Then you can compare. Get the idea about the RL circuit, then you can compare. Now watch the RL circuit. V. This is R. This is L. Right. What is the impedance here? R plus j omega L. What is the magnitude of Z here? What is the phase of the Z here? Imaginary upon real. Right. Now, what is the, let R is variable. Remember guys, I is given by V by Z. Already I have given. That will become magnitude of V, angle is 0 degree. And magnitude of Z, angle is phi Z. So in numerator it will become negative. This is the magnitude of V by Z. Angle will become what? Minus phi Z. Okay. So that is the value of I. Minus phi Z. Now you can draw a table. First, R is variable. What is the magnitude of Z? What is the phase of the Z? What is the magnitude of I? What is the phase of the I? This is the minus of that phi Z. Okay. Now, if R is variable, focus on that. First of all, R is 0. It will become omega square L square because R is 0, so it will become omega L magnitude. And when the R is 0, what is the 1 by 0 infinity? What is the tan inverse of infinity? 90 degree. It is positive. What is the magnitude of I? V by Z. So what is the Z? Omega L. It will become V by omega L only. The magnitude upon omega L, V by omega L. And what is the angle? Negative. This will become minus 90 degree. So it is an inductive circuit. Current lags voltage. So minus 90 degree. It is purely inductive circuit because R is 0. Now you can take R is equal to infinity. When R is infinity, Z will become infinite. When Z is infinity, R is infinity. So 1 by infinity is what? 0. So tan inverse of 0 is 0 degree. And I will become what? When Z is infinity, I will become 0. And this is the minus of phi Z. It will become also 0 degree. Now, in between, if suppose we are having the two values only, again you can draw the phasor. Watch this. Now, it is 0 degree. It is minus 90 degree. It is plus 90 degree. Now, when the R is 0, what is the current? V by omega L, and what is the angle? Minus 90 degree, because it is an inductive circuit. So here you can draw a phasor like this. And what is the length of the phasor? V by omega L. This is a current phasor, so V by omega L. And this value is for R is equal to what? 0. Now you can draw a semicircle, but what the angle? From minus 90 to 0, means it is in fourth quadrant. It is in fourth quadrant. If you want to verify one thing, you can put the value of what? R is equal to omega L. You can also put the value of R omega L. For example, if you are going to put the value of R omega L, so omega L upon omega L, it will become minus 45 degree. So it will become minus 45 degree. Again, the angle is negative. And that impedance, it is also omega L, it is omega L, it will become root 2 times of omega L. So current will become V by root 2 omega L, means 1 by root 2 of the maximum. 1 by root 2. Again you can draw a semicircle, guys. Again you can draw a semicircle in which quadrant? In fourth quadrant. Right? No. In a fourth quadrant, we can draw a semicircle like this. Okay, yeah. This is the semicircle, guys. So the angle will vary from, when R is 0, angle is minus 90 degree. When R is infinite, angle is what? 0 degree. This is the 0 degree. And it is a semicircle. If you want to draw one or more phasor at 45 degree, minus 45 degree, you can draw. And what is the length of that? V by root 2 omega L. This length. V by root 2 omega L. And what is the radius of that semicircle? This is the radius, half of this radius. V by 2 omega L. This is the radius. Is it clear? So in which quadrant? Fourth quadrant. Why? Because it is inductive circuit. Current lags voltage. We are taking the V on this axis because we are taking the V angle 0 degree to V. So with respect to V, current will lags. When it is purely inductive circuit, 90 degree. When it will become resistive, finally it will 100% resistive, then it is a coincide with what? Zero line. But what is the magnitude will become 0. So that is the case. In which quadrant? It is in fourth quadrant. So remember, R will vary from this point to this point. 0 to what? Infinity. Now easy. I think now it is clear. When we are drawing the 4, R is variable. Same logic. Okay. And remember, if you want to draw the Y admittance, again you will get the same. But remove the V. So what is the admittance? 1 by omega L, and finally the admittance will become 0 and so on. So remove this. And you will get the same admittance or same curve for what? Current. So two questions are asked, admittance or what? Current. In case of series, RC circuit or RL circuit or RLC circuit, so you can draw. Then if suppose you are going to vary what? Omega or L. Omega or L. Let for example, omega is variable. This formula will remain same, that formula will remain same. Only there is a change in what? Table. And change in phasor diagram. Omega is variable. Okay, omega is variable. Oh, copy pen calculator, use your copy pen calculator. When R is 0, tell me what is the angle here? When the R is 0, so what is the angle here? R is 0 means it will become tan inverse of infinity. What is the tan inverse of infinity? 90 degree. So when it is 90 degree phase of the jet, so what is the phase of the current? Minus of that, minus 90 degree. Finish. Is it clear? Phase of current is minus of phase of the impedance. So R is 0, to tan inverse of infinity is what? Minus 90 degree. पूरा लिखना पड़ेगा. Watch the recorded lecture, make your notes automatically. Draw 2 or 3 diagram, you will get the idea. Okay, each and every value. Then, for example, I am going to vary the omega. Again, 2 values first, 0. Now watch it carefully. When the omega is 0, this term is 0. So what is the root of R square? R. Now when the omega is 0, what is the tan inverse of 0? 0. What is the magnitude of that? I. Impedance is R, so it will become maximum V by R. Because the impedance is only R, V by R. What is the phase of that? Negative of this, 0 degree. Now it is clear. Very simple. Now finally you can put the omega is equal to infinity, 2 points. If it is infinity, if omega is infinity, it will become infinite, directly proportional. What is this? Now, it is in numerator omega. Tan inverse of infinity is what? Minus 90 degree. Tan inverse of infinity is 90 degree. What is the current? If the Z is infinite, current will become 0. And what is the angle? Negative of that, minus 90 degree. Minus 90 degree. Now you have the 2 points. When omega is 0, current is V by R, angle is 0. The angle, where angle is 0? It is purely resistive circuit. When omega is 0, it is a purely resistive circuit, and that's why angle is 0, and we are taking V here. So current in on same phasor, on same with angle 0. This one. Same direction. And what is the length of this phasor? V by R. Length of this phasor is V by R. Now, second method is what? Draw a semicircle. What is the last value? 0. In which quadrant? All the angles vary from 0 to minus 90 degree. In a fourth quadrant. And that's why this is a semicircle. Right, this is a semicircle. Okay, finished. And now remember, when omega is 0, what is this? V by R. So this value is omega equal to 0. And when omega is infinity, you will reach here. And that's why arrow like this. Omega increases from this point to this point. Okay, omega arrow. If you want to draw exactly at 45, yes, you can draw. Now, where you will get the 45? When I am putting the omega is equal to what? R by L. Omega is equal to R by L. Put here R by L. R cancel, L, tan inverse of 1. What is the tan inverse of 1? 45 degree. If it is 45, it is minus 45. Now, what is the magnitude of that? You will watch. When you are putting the R by L, you will get the root 2 times of R. And the current will become 1 by root 2 of maximum. Always I am taking the 3 values. Here, the current will become 1 by root 2 of the maximum. So this is the R by L. We can say it is a cutoff frequency. Now, at this point, this is the arrow. अरे आ गया अच्छा नहीं लगाया मैंने. This is the arrow exactly at 45 degree. And what is the length of that? V by root 2R. And what is the radius of this? V by R. Radius of this semicircle is V by R. Easy now? So we are getting in fourth quadrant, whether the R is variable or L is variable or omega is variable, but there is a slight change in the diagram. Here when we are taking the omega equal to 0, it will make with what? X axis. Or in that diagram, watch this diagram. Y axis. Okay. That is the difference. But it will remain in fourth quadrant. It is inductive circuit. Or the current phasor diagram or admittance phasor diagram, similar. Because current is directly proportional to admittance. This is called locus diagram. When we are connecting the tip of all the phasor, then we are getting, this is the locus diagram semicircle. In case of RC circuit or in case of RL circuit. Okay. So what is the conclusion? If it is a inductive circuit, it will be in fourth quadrant. If it is a capacitive circuit, it will be in first quadrant. Right? Of suppose it is a RLC circuit, then in a fourth and third both, in fourth and first both. Right? So I am going to draw what? RLC circuit. RLC, series, resistor, inductor and capacitor finally. So if there is any doubt, then you can ask, but you have to calculate it. But on your copy pen, draw it, and next time if you find any difficulty, then please inform me, sir, I am getting the doubt in here and so on. To try to plot it, draw, get the formula for Z, get the phi angle, then compare it. Always remember phi I is negative of minus phi Z, right, and so on, this type. Then now I am talking about the RLC circuit. For example, if you have the RLC circuit, this is R, this is L and this is C. Okay. रेडियस V by 2R, तो क्या लिख दिया मैंने? V by 2R, yes, radius is V by 2R. Half of that, this and that, this one, V by 2R. So we are getting the three values. Now in a case of what RLC circuit, what is the impedance? First write the impedance, then we can draw the table properly. Z, R plus J omega L minus J by omega C. Or you can write the Z is equal to R plus imaginary part. So what is the magnitude of Z? Watch it carefully. R square plus omega L minus 1 by omega C square. What is the phase of that? Phase of impedance, tan inverse of imaginary part upon real part, right? And always remember V and I. What is the relation between V? Just I have taken the V, angle is what? 0 degree. Just reference. I. What is I? As you know, V by Z. That is magnitude of I and angle phi I. And as you know, what is the phi I? Minus phi Z. Because it is in denominator. Minus phi Z. Okay. Yes, in this case, the current lags the voltage, that is the purely inductive circuit. Okay, right. Last case, purely inductive line, it will lag by what? Exactly minus 90 degree. Purely inductive means it will act as 90 degree. This is the point. But exactly at omega equal to infinite, it will become what? 0. You know, first case this is purely inductive. When R is 0 means what? Purely inductive. So it will vary by 90 degree. When it is purely resistive, it will vary by 0 degree. There is a lag by 0 degree. Current lags the voltage. It is a RL circuit. In RL circuit, it is in fourth quadrant. In RC circuit, it is in first quadrant. Okay, it is a, if it is in a fourth quadrant, means it is a RL circuit. But what is the variable here? Omega is the variable or L is the variable. What is the variable here? R is the variable. So we have the different types of diagram. At the end, we will conclude. Now, we have the different values, guys. We will plot it, but first of all, get the idea about what values here. This is a very, very important again, but the value will remain same. we are going to vary the omega directly. Normally omega is variable, so omega. What is the magnitude of z? Phi z. Magnitude of I, phi I. Okay. Tell me. Watch it carefully, no? Watch it carefully. When omega is 0, so I have to give the two values, two more table, na here. Otherwise, you are not going to get the idea about that. रुक जाइए. Now, let the omega is variable. First, what is the effect on impedance of ZC? What is the ZC? 1 by omega C. What is the effect on ZL? What is the ZL? Omega L. What is the overall Z? What is the phi of Z? And then what is the I? And what is the phi of I? Okay, and that is the case. I think now it is more informative. Tan inverse of imaginary upon real. Imaginary upon real, guys. Then when we are going to take the omega is equal to 0. Omega is 0. Omega is 0. Tell me, what is the ZC? ZC is 1 by omega C. It will become infinite. What is this? Omega L will become 0. Means it is a purely capacitive. Because it is a capacitive, impedance is very, very high. Then in which quadrant? Tell me in which quadrant? But when the any one of this is infinite, overall impedance will become infinite. Phi z, watch this. When the omega c is infinity, this term is completely become minus infinite. What is the tan inverse of minus infinite? Minus 90 degree. I will become 0 and angle will become plus 90 degree. Angle will become plus 90 degree. Plus 90 degree. That is the case. Exactly at resonance frequency. What is the resonance frequency? 1 by root over LC. Exactly at resonance frequency, as you know, this term, imaginary term will become 0. Because we are getting a resonance frequency, imaginary term will become 0. So what is the impedance? Both. This is the 1 by omega c, that is 1 by omega L. So just I am writing the magnitude of ZC will become equal to what? Magnitude of ZL. And that's why it will become purely resistive. When it is a purely resistive, this term will become 0. What is the tan inverse of 0? 0 degree. What is I? I will become maximum V by R. And what is the angle of I? Again it will become 0. Again, in a purely resistive circuit, phase difference between voltage and current is what? 0. So it is in capacitive circuit, the angle will vary from 90 to 0. And now if you are going to keep the infinite, watch it carefully. If it is infinity, inductive capacitive impedance 1 by omega 0. Inductor infinite, means it is a purely inductive circuit. Impedance of effect of inductor is high, infinite. Magnitude of Z will become infinite. Why infinite? Because this term is infinite. Angle, this term tan inverse of infinity, positive value. Tan inverse of infinity, positive value, and that's why it will become 90 degree. It is inductive circuit, 90 degree. Impedance is 90 degree. what is the current will become 0 again. But what is the angle of that? Minus 90 degree. So from this point to this point, it is in which quadrant? Fourth quadrant. So it is in this range, it is in first quadrant, it is in fourth quadrant. It is a capacitive circuit, it is purely resistive, and it is inductive circuit. So guys, now if you are going to make a, watch it carefully. Okay. Exactly what will happen, we are getting the maximum value of the current under resonance, as you know. So you can start with this. This is the maximum value of the current under resonance. And what is the value? V by R. What is the value? V by R under resonance. And at this point, that frequency you have idea 1 by root over LC, and that is the V by R, and voltage is on the same. It is the voltage. So V and I are in the same phase. Now, when we are varying the omega for capacitive circuit, already you have the idea semicircle. You will get this type of semicircle here. Right? Now here the omega is equal to 0. It will vary from 0 to what? This point. 0 to this point. And exactly at resonance frequency at this point, omega, the value of omega is 1 by root LC. It will become purely resistive, and that is what? It is a 90 degree. So current leads by 90 degree. Exactly at 0, it is purely capacitive, because the capacitive impedance is infinite. You will get the semicircle. Now, from resonance frequency to up to infinite, again it will enter into what? Fourth quadrant. Where is the fourth quadrant? This is the fourth quadrant. Now we have to cover the complete circle here. This type of circle. Okay. Now omega will vary again. At this point, it will vary from this point to infinity. At infinity again, what is the current? 0. What is the angle? 90 degree. It will make a tangent with what? 90 degree line. This is the 90 degree tangent with this circle. So here it is a capacitive circuit, here it is a inductive circuit, and that is the locus diagram. That is called locus diagram. This is the locus diagram for current. It is also the locus diagram for Y, admittance, circle. And what is this? In a clockwise direction. Circle is in clockwise direction, guys. So will vary from 0 to plus 90 to 0, then 0 to what? Minus 90. In first quadrant it is capacitive, in fourth quadrant it is inductive. So we have drawn the 3 points exactly at 0, exactly at resonance frequency it is purely resistive, here it is a purely capacitive, here it is a purely inductive. 3 points. And variation of omega here. Any doubt in this diagram? Series RLC circuit. Table is important. At resonance, these are equal. What is the radius? What is the dia of that? V by R. What is the radius? V by 2R. V by 2R. That will be the question ना. पूरा ऑब्जेक्टिव देखना ना कैसा, ऐसा ही तो आया. No, it is on the, if you have the command over the table, then directly you can relate. Otherwise, without table, it is very difficult. What is the variable? What is the variable? What is the effect on ZC? What is the effect on ZL? What is the effect on Z? We can't. But here we can relate. What is the phase of I? What is the phase of Z? What is the phase of admittance? Admittance and current directly proportional. Then that's why we are getting the same circle. Okay. So because it is always remember, if you are getting the Z is equal to infinite, then it will become difficult to draw the Z. But when the Z is infinite, what is the Y? Y admittance will become 0, and that's why it is easy to draw for Y or either I. But it will become difficult to draw the diagram, phasor locus diagram for what Z, because it is infinite. So how we are going to represent the infinite? That's why I or Y. Why we are getting the same locus diagram? Y will just remove the V. Remove the V, it will become 1 by R and so on. You will get the diagram for Y. Because Y is, what is the admittance? I by V. Just remove the V or take it what 1 volt. So both have the same phasor, V, Y and I. Now, similarly, guys, you can draw it for what? Parallel circuit. For example, in a parallel RLC circuit, if any question is given on the parallel RLC circuit on same logic, then we will solve some questions. No? So which one will become infinity? Admittance will become infinite. For example, this is a parallel RLC circuit. Or this is G. What is the G? 1 by R. V. Okay. Now, for this parallel RLC circuit, what is the Y? Directly you can write the Y. Y will become G conductance plus J omega C, that is the YC, minus J by omega L, that is the YL. What is the admittance? G plus J omega C minus 1 by omega L. Same logic, no? Same. What is the magnitude of Y? Root over G square plus omega C minus 1 by omega L square. What is the phase of Y? Tan inverse of omega C minus 1 by omega L upon G conductance. And then now you can draw a table. Finished. Yes, if you are going to change the R, then there is a change in what? Table. But normally we are not, we are getting question on what? Omega. Because when the omega is variable, we are getting what? Resonant frequency. We are getting resonant frequency at particular value. That is 1 by root over LC. Okay, otherwise now, if anything is variable, you can draw the table and you can plot it. Is it clear? Now, this is the G. Similarly, here again we are going to vary what? Omega. But remember, in a parallel circuit, if Im is given, so just I am taking the I is equal to what? Im angle 0 degree. Right? Now, it is the reference to what will be the voltage V. What is the relation V and I? Remember, V is equal to what? Iz. Or I by Y. It is inversely proportional to that, and that's why the angle of V will become negative of what? Angle of Y. Angle of V will become negative of angle of Y. Y means admittance. जो भी इसका angle है उसका negative हो जाएगा. Why? Because it is in denominator. Right? Same logic, same table, same phasor, but it is a parallel RLC circuit. You can draw. omega YL YC magnitude of Y, magnitude of V, angle of that. This is the omega YC YL overall Y, phase of Y, magnitude of V and angle of V. Right, very simple. Omega equal to 0. What is the YC? Remember, YC is omega C. This is YC is omega C, magnitude is omega C. So YC is 0 means it is 0. YL will become infinite. If any one is infinity, watch this. If it is any one is infinity, overall Y will become infinite. And if it is infinity, minus infinity, because 1 by omega L, this is 0. And this term is infinity. And that's why the angle will become 90 degree, minus 90 degree. Because of this term, angle will become minus 90 degree. What is the V? V will become 0. Why? Because Y is infinity. So it is the I by Y. V will become 0. And angle will become negative of Y. So negative of Y is what? Plus 90 degree. Finished. Is it clear? Very simple thing. Now, exactly at resonance frequency, 1 by root over LC. 1 by root over LC. This term will become 0. And the admittance because of C is equal to what? Admittance because of L. Both are equal. And this imaginary term will become 0. So admittance will become G. What is this? Angle will become what? 0 degree. At the resonance, it is a purely angle. And we are getting what? V maximum, because G is minimum. What is this? I by V. I am by V. I am by G. I am by G, because Y is G, and what is the maximum value of I? I am. Angle is 0. So I am by G. This is the maximum value of the voltage. And if it is 0, what is the angle? 0. Finally, when I am taking the infinite, YC will become what? YC. This is infinity. This term will become infinity. This term will become 0. Overall impedance will become infinity. Right? It is a capacitive circuit. Then what is the YI? Phi I. This is omega C is infinity. What is the tan inverse of infinity? Because this term is infinity, positive infinity. Tan inverse of positive infinity is 90 degree. Voltage will become 0 and the angle will become minus 90 degree. Now guys, remember, in case of parallel RLC circuit, we are taking the current as a reference and we are drawing what? Voltage or what? Impedance. Why voltage and impedance? Because voltage is directly proportional to impedance. So either you can draw the phasor diagram for V or what? Z. V or what? Z. Okay. V or Z. So normally they will ask, and again watch it carefully. It is a very simple one. This is 90 degree. This is minus 90 degree. This is 0 degree. Now watch it carefully. Now, exactly when the omega is 0, what is the voltage 0? What is the angle of the voltage? 90 degree. Where is the 90 degree? This is the 90 degree. And exactly at resonance, what is the value? Im by G. Angle is 0 degree. So this is the point. You can start with the resonance. But this time it is not a current phasor, it is a voltage phasor. It is a current we are taking on the 0 degree axis, and this is the voltage. Now you can draw a semicircle like this. Finished. Yes, this is a circle. Now here omega will vary. Here the value of the omega is 0. Reach up to what resonance frequency, and again it is become infinity. Okay, is there is any doubt? So what is the phasor here? It is the phasor for it is a locus diagram for voltage or what Z. You can't draw the phasor for what locus diagram for Y, because Y will become infinite at this point. Y will become infinity at this point, infinity, but you can draw the Z because Z will become 0. When the Y is infinity, Z is 0, or V or I, Z proportional to each other, and that's why similar type of diagram we are getting in parallel RLC circuit. In parallel RLC circuit, we are getting the similar type of diagram. Okay. So arrow, it is also important to watch the arrow, whether it is a clockwise direction or anti-clockwise direction. That's why there are 4 types of option: clockwise or anti-clockwise. 0 in a first quadrant, then it is in finally here. What is 90 to 0, 0 to what? Minus 90. So already I have given, please watch the recorded session, and then guys, which type of question, for example, that is the question in previous year paper. Now, first of all, this RLC series, so is supplied from the variable frequency voltage source. Variable frequency is variable. The admittance locus Y of the RLC network at terminal AB from this point to this point, okay, no problem, RLC are in series, for increasing the frequency of omega. Already we have drawn admittance locus for RLC circuit. Which answer is correct? Now you can watch, these two diagrams are same, and that is our answer. But arrow, where we are going to move the arrow? When the omega is 0, it is a capacitive circuit. The angle will vary from in first quadrant. When omega is more than resonance, it is inductive circuit. It is in third quadrant. And which answer is correct out of A or B? So already I have given, when omega is less than resonance frequency, it is capacitive circuit. Arrow is important. That is the objective question. So arrow means what? This is 0. This is 1 by root over LC. Resonance frequency, it is purely resistive, and then again at infinity it will become 0. Here it is a capacitive, here it is a inductive. It is the first quadrant, it is fourth quadrant. Okay, time is now. Okay, and this is the B is the answer. Now it is time for assignments. So try to solve this question. Then assignment. In weekend we will solve all the questions. Tomorrow onwards I am going to start new topic. So please watch the session. Try to draw this. Very, very important one. Automatically you will get the, but phasor sum. Now I will give the answer. Then already I have solved. This is the answer B. What is the locus of the tip of the voltage phasor across R? Now this is the, what is the locus of the tip of the voltage phasor? This time it is the voltage phasor, not the current phasor, across R, only R in series RLC circuit. So what is the across R? If you have the current phasor I into R, this is the voltage across the R. So R is constant. So R is constant. I is variable, so I we are getting which type of I we are getting in RLC circuit, a circle, and then it is a circle. So yes, but read this. I have given the hint. IR. Okay. Then in a series RLC circuit, the locus of the tip of the admittance phasor in the complex plane as the frequency is varied. Already I have given, just remove the what V from the I phasor, you will get the phasor for Y. Already I have solved to. Try to solve this question. In I phasor we are getting V by R. Suppose we are getting the V, so you can remove the and then it will become 1 by R for Y phasor. First just remove and you can draw. This is about the admittance phasor, and it will boost your, this is the previous year questions of GATE exam. It will boost your confidence that you have the command over what locus diagram. So try to solve this question. This is the assignment. Okay, and then we have more questions. Already yesterday I have given the assignment, but we will solve what? This is the question. Width of the resonance curve in RLC network is determined by which one of the following? To try to solve this question. Then already yesterday I have given, so we will solve all the questions in what? Weekend. Okay then. Thank you very much for attending the session. Guys, try to solve all the questions, but before solving the question, get the command over concepts. Go through the lectures, all the 3 lectures on resonance and locus diagram, part 1, part 2 and what? Part 3. And first get the command over the series resonance, then get the command over parallel resonance, then locus diagram. What is the locus of I? What is the locus of V? What is the locus of Y? What is the locus of Z? And try to get the command over first of all RC circuit, then RL circuit, then RLC series and RLC parallel. Okay, and then you will be able to solve all type of questions. And then solve these assignments. On this weekend we will solve all these questions. Okay then, thank you. Have a nice day.